Hello everyone, and welcome to me doing some examples very similar to the Chapter 7-8 review. So with the Chapter 7-8 review, if you scroll to the back page, you will find this list of data, the GPA of people when they were in high school, and then this is when they were in college. So they're paired up by person. So first thing you'll need to do is put these in list 1 in your calculator, and these in list 2 in your calculator. Now I'm not going to do the exact same problems, I'm going to do similar problems. So what I've got is, instead of GPAs, I have exam scores in a calculus class compared to exam scores in a pre-calculus class. So the first thing I need to do is put the calculus scores in list 1 and then the pre-calculus scores in list 2. Now I'm not going to sit here and type them in and make you watch me type into a calculator, so I did that before. Looks like I can't see it that well. So I did that before you got here. So there they are in the lists. I just have to dim it for a second so you could see the calculator-ish. Anyway, they're there. And then I need to find the mean and standard deviation for the first list. So there we go, trying to brighten it up for you. Okay, so I just go to the stat, calculate the one variable statistics, and then tell it list 1. And it says that the average, so I'm just going to write this down on the side. So this first question is about the calculus students. The next one is pre-calculus. So for one, there's 17 students, so I've got n equals 17. The average is 81.882, and then S, the standard deviation, is this 10.386. So S equals 10.386. Okay, now switch back over. I need to get it brighter again. Sorry, not exactly professional editing. There we go. Now we're ready. So test the claim that the calculus class has an average that's over 70. And notice in bold, I said to put all of these things. So the N, I've done that. The mean, I've done that. And the S, I've done that. Next up, the claim. So I write down the claim, and then the average, that's referring to the mean, and the mean for the population is the symbol mu, so mu, and then over means bigger than, so bigger than 70. And if you look at the average, yes, it looks like that definitely is over 70, but is 17 people enough to prove it? Or another way to say it is, just because this class did well on the first exam, in general, is this enough evidence to prove that they are always going to be doing better than 70? All right, that's the claim. Did that part. Next, H1. So H1 is called the alternate hypothesis, and the main rule for this one is it cannot have an equals sign. Since this does not have an equals, that means it stays the same. If the claim had an equals in it, then H1 would be the opposite of that. Next, so I did H1. Next, HO, that's the easiest one because no matter what anybody else says, it always says equals. So there's that part. Next, all right, I'm done with HO. Next, the critical value. So this is based on a t-distribution, which is a normal distribution. And when you look at H1, it tells you how to shade the graph. Since this arrow is pointing to the right, it's going to be a right-tailed test. So there's only one shaded part over here, known as the right tail. And in the claim, or in the sentence, I did not say what level of confidence to use. Whenever that's not said, we use 95% level of confidence, which means the blank part of the graph is 95% of the graph, and the tail is going to be 5%. Now for the critical value. So when you have a claim about a mean, that's the t-distribution. So I need to get table A3. And up here it says in one tail, because we only have one tail, the one tail has 0.05, so that means I need to be using this column right here. And then degrees of freedom is going to be n minus 1. So n was 17, that means degrees of freedom is 16. So use this column that has the 0.05 for one tail, and then go down to where degrees of freedom is 16, and that is right here, a 1.746. I realize you may not be able to see that clearly, but believe me, it says 1.746. So the critical value is 1.746. All right, that part's done. Next, the test statistic. And you can use the calculator to do that. Again, that makes it a little bit hard to see. So let me adjust it. So you go to the tests, and then it's called the t-test. So when it's about the mean, you use the t-test. And you could use the data because it's in the list. If you want to just type the statistics yourself, in other words, type these numbers in over here, you can do that by going to stats. So you can go to data, and then this number is saying, when you look at H sub O, what number do you see? So that's a 70. And then tell it which list to use, which I'm using list 1. Frequency just means every time you typed in a number, there was just one of them, so that's correct. And then this symbol is coming from the H1, and then that is got the greater than. And then calculate. So it says that T, or the test statistic, is a 4.717. So 4.717. So I like to label it test statistic. T equals 4.717. All right, I did that part. And now the conclusion. So a 4.717 goes way past a 1.7, and as long as it goes past this 1.746, which it did, that means we actually did prove something. So technically you then say the H sub O is false, which means, is the class going to equal a 70? No. They're going way over to the right, which is actually much better. So the claim is that they were going to, on average, do better than 70. This is going to the right, which means this is correct. And as you can see here, yes, they're doing better than 70. So then the claim is true. And then I'm done with the conclusion, and I'm done with number 1. So by the way, if this would have turned out to, let's say it was a 0.7, it would have landed in here. Anytime it lands in this blank part, that means we did not prove anything. It's not true, it's not false, we just don't know. Now, number 2 is very similar, just using list 2, but the setup would be the same. The numbers in here would be a little bit different because I'd use a different list, but the work would be basically the same. And if you look at the actual chapter 7, 8 review, so this is test the claim that their high school GPA, so that would be list 1, has a mean of, so this is saying it's equal to a 3.0. Then later, it's pretty much the same work, except you use their college GPA, or in other words, list 2. So that's very similar. Now, before I go on, there is one other thing I want to do, because this is chapters 7 and 8, and that is make the confidence interval. So switch back to the calculator, and for that, all you need to do is go to stat, over to tests, and then go to number 8, the t-interval. Then just tell it which list. Yes, list 1. Confidence level 95%, so that's good. And then calculate. So basically this is predicting the future, saying, well, based on the evidence we have, this class is going to end up somewhere with an average between 76.5 and 87.2. So the confidence interval would be that they are somewhere between 76.543 and 87.222. All right, then on to another question. Test the claim that the majority, and the word majority means over 50%. And then this is the calculus students. Oh, sorry, let me adjust this. Okay. And this is for the calculus students. And do they have a C or better? So a C would be 70 or better. So now I just need to find that list again and see for the calculus students. So for one thing, there's 17 students. I already know that. And then how many have a 70 or better? So 1, 2, no, 3, 4, 5, 6, 7, 8, no, 9, 10, 11, 12, 13, 14, 15. So 15 out of the 17, because not this person and not this person. So 15 out of the 17 have at least a C. So I write down that information. N equals 17 people. X equals 15 have at least a C. And then that would be 15 out of 17 is, anybody can do that in their head? Well, not me. So that's 88.2. So as a decimal, 0.882 or 88.2%. So yes, that definitely looks like over 50%, but then again, it's only 17 people. Is that enough evidence to prove it? Okay, so test the claim. So like with the last one, I need to write down all of the parts. So the claim is that the percent, or in other words, the majority, the percent is over 50%, but I write it in decimal form, so that takes care of that. Like the last one, this is saying greater than, so that means that it's going to be H1 is the same. Since the claim doesn't have an equals, then H1 stays the same. And again, this is pointing to the right. And like always, H sub O ignores everybody else, does its own thing, and just says equals. Now to drawing the little graph, so here's the normal distribution, and it's going to be a right tail according to H1. And again, I did not say what to use for the level of confidence, so when that happens, use 95% as the level of confidence. And then that means that for the tail, there's 5%. Now when it's a claim about the mean, like the last problem, we use table A3. When it's a claim about proportion, use table A2. So I need to get table A2. Ta-da! And with table A2, it's always looking at what's on the left. So that means I'm looking for 0.95. And as I search through the table trying to find the closest thing to 0.95, I notice that there's a tie right here between 9495 and 9505. And there's even a little star. And if you follow that arrow down, it says if you were looking for an area of 0.95, then the critical value is 1.645. So that's what goes on the graph. The critical value is 1.645. And now we could use the calculator to do the test. So for the test statistic, and then my little iPad here. There we go. I think you can see that. I can see it, so hopefully you can. So you go to Stat, go over to Test, and then it's going to be number 5, 1 proportion z-test. So first of all, look at h sub o and whatever that number says. So that's a 0.50, so 0.50. And then x, how many successes? There's 15 people that have a C or better. And then that was a total of n equals 17 people. And then it's supposed to be a right tail, so it goes like that. And the magenta does not matter. Then go to calculate, and it says that the z is a 3.153. So 3.153. So z equals a 3.153. And then, as you could see, a 3.153 definitely goes past 1.645. So that means that the h sub o is false. So we actually did prove something. In other words, when this said it equals 50%, it's false. As you can see, it's actually way over 50%, which is what the claim said it was going to happen, so the claim is true. Okay, so that is from Chapter 8, testing the claim, and then to just step back real quick and do something from Chapter 7, let's make the confidence interval. So for the confidence interval, I just go to Stat, Test, and then look for, there it is, 1 proportion z interval, letter A, 1 proportion z interval. And the calculator even remembers the numbers were 15 and 17, and the confidence level is 0.95, so we're ready to go. So this is basically saying somewhere between 72.9% and up to 100% of the class could get a C or better. So this one didn't ask for the confidence interval, but just in case it's asked for, that's how you make the confidence interval. So it would go from 0.729. On the other side, it would be 1.036, which is actually represents more than 100%. So technically that's not possible. It's saying somewhere between 72.9% and maybe up to 100% of the class could get a C or better. Okay, so that was the review of, well, it was sort of the review of the review, or practice for the review, chapters 7 and 8. So this is like the first one I did. This is like the first one I did. This one, as you can see, it has the word majority. That's exactly what I just did on the last one. This one is also the majority, so that's just like the last one I did. And then this one is college, and the previous one was high school. So everything so far is exactly like I did. Now, the rest of it is also going to be the same, except I ask you to separate the data. So those with a high school GPA under 3.5, and then those that have bigger than a 3.5. So you look at their high school GPA, and first of all, highlight all the ones that are under a 3.5. So under a 3.5, I said under 3.5, so this is not going to be under 3.5. This one, under 3.5, under. Here's some more. And then under 3.5, I just keep saying it to myself so I don't forget. Under 3.5, under 3.5. Okay, so all the ones with X's are the ones that are under 3.5. So these are X's, and then these are blank. You could highlight them and make these yellow and these pink or something like that, but I'm just going to use an X and a blank. So test the claim that the mean college GPA So for those that have under the 3.5, so in other words, the ones with X's, you're then going to look at their college GPA. So all the ones with X's, you would then move over. And if I had a highlighter, I would have just highlighted straight across, but I forgot to get a highlighter, so I'm just making my own highlighter like this. All right. Now the question is actually about their college GPA. So you'll need to get your calculator, clear out the lists, because we're done with those old lists. And now in list 1, you're going to put their college GPAs for just the people that have the X's. So you would put all of these in list 1, all of the ones that now have an X and a check mark. And then the other ones are going to be the next question. So these other ones, you would put them in list 2. And then after you do that, the work is going to be very similar to the very first question I did on this video. So this part is saying the same thing, but here's the part where I ask for the confidence interval. So on the first part of the video, when I did those 2 examples, I did test the claim first. And then I said, oh, let's throw in some chapter 7, the confidence interval. So that's what these are asking. And notice there's not a lot of space, because when you do the confidence interval, sorry, I'm trying to get the correct page. Here it is. When you do the confidence interval, you basically only need to write down this part, then use the calculator and write down this part. So that's the reason there's not very much space, because you just need to write down that and then that. So you could fit that right in there. All right, I hope it helps, and I'll see you soon.